Let's talk about Schrodinger's time dependent and time independent equation. We can derive Schrodinger's time independent equation from Schrodinger's time dependent equation. So the logic is that first we will derive, or we can develop the Schrodinger's time dependent equation. It's not really a derivation. It's like we are getting a result by putting in places the different functions and using the concept of de Broglie wavelength and writing down the wave equation and so on. So in general, we know whenever we are basically considering equation for a wave, this has to be periodic. That is the first condition that we should actually consider. It has to be periodic. So whenever we are considering a periodic wave function, it's more or less having a cos or a sine function. So that's very important. So here what is happening is that we basically have a wave which is this. Okay, we can consider the idea of de Broglie wavelength, and we know that the wavelength of that is h divided by p, where p can be written as momentum, which is mass into velocity. Okay, so if there are particles because of which the waves are getting created, their mass and velocity will play the role in finding out this wavelength. So if we basically have a plane wave, it is any plane wave. Okay, it can travel from one point to another, so it is a plane wave. This equation in general can be written in this form: psi rt is equal to a to the power I k dot r minus omega t, where psi is the wave function, as we have already discussed that if we talk about sound, the idea is that pressure is something in between because of which there is a traveling of sound from one point to another. In a similar way, if you are talking about matter waves, it travels from one point to another. The main function that we consider is called as the wave function. So the wave function is denoted as psi, and it is a function of r and t. So it is time and position both. Okay. So if we write down an equation for this, we can first write down the amplitude. So we can write down the amplitude, and then we can write down this general equation. Now you might wonder why we are writing down e to the power I theta. Okay, so the reason is that it has to be periodic, and e to the power I theta is a function of cos theta and sin theta. So e to the power I theta is equal to cos theta plus I sin theta. So that means this is a periodic function. So this is the general form of the wave function, and this we can write down in different form. For example, if I want to write down the momentum, I can write it down p is equal to h cross k. So k can be written as p by h cross, and I can replace it here. I can write down E is equal to h cross omega, and omega can be written as E by h cross. That also can be replaced here. So I can write down this equation in terms of momentum and energy as well. So that both will actually give me similar result. So if I want to find out the energy associated with that wave, I am actually considering the mechanical energy. So mechanical energy means that it is a combination of kinetic energy and potential energy, and we know kinetic energy is equal to half mv square, and half mv square can be written as p square divided by 2m. So আমরা যদি write down half mv square, okay, you can multiply it with m, okay, and you can divide it with m. So it will be m square v square. Mass into velocity is momentum, so it will be p square. So half p square divided by m. So it is p square by 2m. So this is the energy. But in quantum mechanics, what happens is that these parameters that we are talking about, it may be the momentum, it may be the potential energy, they will keep on changing. Okay, it will be a variable of time. That means with time it will change. Okay, you have to understand that logic. That's important. So for that, what we do is we write down this momentum in terms of the momentum operator. This is the momentum operator, and this is, you have to remember, I minus I h cross delta, and this is the energy operator, I h cross del del t. Operator means that I have got this, and I will be operating with this on the wave function psi. Okay, and then we are going to find out the equations. So in general, if I want to say that what is the energy, I can simply write it down as E into psi. So E into psi will be actually giving me the total energy. But what is E? E is h cross omega, so I can write it down as h cross omega into psi. Okay, or we can also write it down as E into psi. Okay, so in simple words is this. This one also something like that. Okay, h cross k into psi, which is equal to p psi. That is possible. So if I want to derive or develop the time dependent Schrodinger equation, then we have to start from the Hamiltonian. Now in quantum mechanics, the total energy is obviously kinetic plus potential energy, but it is termed as Hamiltonian. So if someone tells me Hamiltonian of a system, that means we are going to talk about the total mechanical energy of the system, money addition of kinetic energy or potential energy. Now আমরা এনার্জি কে কি দেখেছিলাম, টোটাল এনার্জি ওয়াজ এ কম্বিনেশন অফ কাইনেটিক এনার্জি প্লাস potential energy. Now I am having a wave function. That means what is the energy associated with that wave function? So that means I have to multiply with energy E into psi RT. So I am multiplying it E into psi RT. Okay, so that's why we are multiplying it with E into psi RT. So this side I have taken psi RT, so this side also I have taken psi RT, and then I have to multiply this. Now let's change it into the operator form. What was our E? E was, this one you have to remember, as I said, I h cross del del t. So in place of E, I'm going to write it down I h cross del del t. And on this side, what I can do is, in place of momentum, I can write it down as minus I h cross delta whole square divided by 2m plus VRT psi RT. So this is the momentum operator, this is the energy operator. You have to remember it and accordingly you have to replace it. Okay, and then what happens is we can find out this term minus I h cross delta whole square. माइनस स्क्वायर को ले लोगे तो प्लस हो जाएगा, आई स्क्वायर को ले लोगे तो it will become minus 1, so it is minus, and then h cross square you take, then it will be h cross square, and delta square you take, it will be nothing but delta square. So I h cross del del t psi RT, it will be same, is equal to, यहाँ पे इसको replace कर लेते हैं, it will be minus h cross square delta square, so it is minus h cross square delta square divided by 2m into psi. So this psi is there, I am taking it here, this psi RT plus VRT psi RT plus VRT psi RT. This equation is the Schrodinger's time dependent equation. So if someone tells you to show what is the Schrodinger's time dependent equation, you can do this, and this is the expression. But the thing is, you have to remember this expression, that is very important. Okay, what it means is that this wave function will actually change with time. It is not going to be time independent, it is going to be time dependent. In simple word, it means that, let's say we have got an atom, okay, and there are waves which are continuously hitting the atom. So that means the energy is getting transferred from somewhere to the atom, and it is happening at a continuous rate. So that means after some time the state of that atom will be different, after some more time the state will be again different, because it is absorbing more and more energy. So that means for such system where the system actually changes with time, I have to use Schrodinger's time dependent equation. But if there is a system, let's say there is a neutron or a proton inside a nucleus which is not moving anywhere, it is at rest, that means the neutron and proton will remain the same, the energy states will remain the same, as we are not applying any external energy with time, it's not going to change. So that means there we can use Schrodinger's time independent equation. So we have seen the dependent equation, and we can find out the independent wave equation from this equation itself. Okay, so if I want to find out the Schrodinger's time independent equation, okay, I have to somehow remove these. Okay, so if I think easy. So if I derive the Schrodinger's time independent equation, for that I have to consider the Schrodinger's time dependent equation. In your exam, you don't know which one will be asked. If they are asking you Schrodinger's time dependent equation, you can answer. Okay, then you have to answer whatever we have done till now. But then if they are asking you Schrodinger's time independent equation, then you have to remember Schrodinger's time dependent equation, and if you remember that, then only you can answer the Schrodinger's find out Schrodinger's time independent equation. So that's why a thumb rule is to remember both Schrodinger's time independent and dependent equation. The reason is you will also use Schrodinger's time independent equation to find out different terms, but this is not very difficult. Okay, because I will give you a trick where you can remember both the equations. Okay, so let's just try to revise this. Okay, So let's say I have got Schrodinger's time independent equation as this. Okay, let's say I remember this equation. But what is psi? Psi is a function of r and t. Now I want to get rid of t. So for getting rid of t, because it is time independent, I have to write down this psi rt as a function of two different functions. Okay, one is only a function of r and one is only a function of t. So this is the idea of separation of variables. Okay, separation of variable. So we are writing down psi rt as phi r into tt. So that's why I've written down it as I h cross phi r dt dt. So as we said, if you look here, we are doing partial differentiation because this psi is a function of both r and t. But now if I separate it out, if I am differentiating with respect to t, I have got a function which is a pure function of t. So this capital T is a pure function of time. So I have taken this as dt dt. So it is not partial differentiation, it is total derivative of this. And phi r I can take it out. Similarly on this side also I can write it down minus h cross square divided by 2m into delta square phi r, and t I have taken it here, plus Vr into phi r into t. So I have taken this t out and I have kept this term inside. Okay. Now what we are doing is we are going to divide. Okay. So now what we are doing is we are going to divide both sides. Okay. We are going to divide both sides by phi t. So this was our phi. Okay, and this was our t. This was our phi and this was our t. I have just dropped the bracketed term so that it looks easy. Phi t. So if I divide this term this side by phi into t, phi will get cancelled. I will be left out with only t. So I can write down I h cross 1 by t dt dt is equal to minus h cross square by 2m. Again, if I divide this by phi into t, this phi and will be there. Okay, it will be there into t will get cancelled out. Okay, phi will remain. So 1 by phi delta square phi plus vr के साथ तो phi t भी है tt भी है, तो दोनों को divide करेंगे तो you're just going to get vr. So this is my equation that I have. But if you look into this equation, what is I h cross d dt? I h cross d dt is nothing but the energy, right? So this is nothing but the energy. So that means on this side, okay, on this side I can change. I can simply write down this entire term as E, and then I have got E, and there would be a psi. Okay, this is the wave function that we have phi. Okay, yes, phi into t, correct. Yeah. So that means that I can write down this entire term in just E. This is just energy. Okay. Why this is energy? Because this energy is the total energy and it does not change with time, because we are talking about Schrodinger's time dependent part. Okay, so the time part will become just E, which is the total energy, where the function is e to the power I e t by h cross. But anyway, we're not going to use this. And if you look into the space part means this part. Okay, if you look into the space part, you see it is minus h cross square by 2m del square phi r plus v r phi r, okay, is equal to e phi r. So there is a phi here. You take an LCM. If you take the LCM, entire LCM would be phi. Here you will have this term, and on this side you have to multiply it with phi because ये phi यहाँ चला जाएगा, and then you cross multiply, you take the phi here. So this E, this will be E, this entire term is E, and you multiply it with this phi. So this phi, so it will become E into phi. This is the Schrodinger's time independent equation, which is having more applications. Definitely we're going to look into one of the applications right now. So this is the Schrodinger's time independent equation, where you can simply write it down as minus h cross square by 2m del square phi r plus vr phi r is equal to E into phi r. Now whether you want to write it down as phi or psi, it's totally your choice, but you have to just make sure that if the question is based on Schrodinger's time independent equation, then this psi is only a function of r. But if the question is on Schrodinger's time dependent equation, then this psi is a function of both r and t. So if I've replaced it with phi because I've used the notation, even some books you'll see they have written psi also. But you have to understand that this psi is only a function of r and not of t, okay, and not of time. So this is exactly what we have done, and this is our Schrodinger's time independent equation. Now, how do I remember both these equations? That's an important thing. So what you can do is you can just remember one of them. So let's remember this. This is minus h cross square by 2m del square psi r plus vr psi r is equal to E psi r. If you remember this, you can also remember Schrodinger's time dependent equation. In dependent equation, what happens is this energy function is written in terms of the time operator. So if you look here, it's the same equation. Okay, if you look here, it's the same equation we're writing down, the same thing. But here, this in terms of E, in place of E, I'm writing down I equals del del T, because that's your energy operator. So this is how you can easily remember. You remember one and then remember the other one easily. For example, if you remember this, then you know that I equals del del T is energy. So just write down E psi. That's it. Okay. यहाँ पे psi function of R and T, वहाँ पे psi only function of R. It depends what notation you want to use. There is no issues. But please remember, this is only a function of R and there is no involvement of time here. Okay. So that's important. So this is how you write down Schrodinger's time independent equation. So in general, it will be around 5 to 7 marks, and dependent equation will be there. It's usually shorter, so it will, 3 to 4 marks, depends. They ask both, then it will be a descriptive question and so on. But then, what is the application of these equations? Okay, so we're not going to discuss the application of Schrodinger's time dependent equation. We're going to discuss the application of this Schrodinger's time independent equation. तो पहला चीज तो है कि you have to remember this equation, okay? And next imagine a situation. Situation is that you have got a particle which is a subatomic particle and it is trapped inside a box. Subatomic particle means it can be a electron, or it may be a neutron or a proton. So if it is an electron, it is trapped inside the atom, and the dimension of the atom is 10 to the power minus 10 meters. So that will be the electron trapped in a box. But if you consider a neutron, that will be more closer to reality, because electron has got a fixed point where it can move, but a neutron will be within that sphere. Okay, it will be a kind of well. Okay, so it will be trapped inside a neutron or a proton. You know the mass, so you know this much mass is trapped within nucleus, and the dimension of nucleus is 10 to the power minus 15 meter. So this is the idea of particle trapped in a box. So the concept is that inside the box it can easily move around, so the potential would be 0. So let's say the dimension of the box is 0 to A, okay? That means the length is 0 to A, or we can say the potential box of the well is having a width A. So you know it is there inside and it will be 0. But this particular proton or neutron cannot be on the wall, or it cannot be outside the wall. So that means the potential is infinity. Potential infinity means it cannot move out, or it cannot be there at that position. For simple way to understand this is, suppose the door is open and then there is the wall, okay, inside a room, okay. So you won't be crossing the wall, right? You cannot move out of the wall, through the wall, okay, out of the room. You need to go through the door which is open. So that means the potential of that wall is very high. That means it is infinity. You cannot break it. Okay, so that means you cannot exist on the wall, you cannot exist outside the wall if you are going through the wall. So that means you have to take the easier way. Inside the room it's very easy for you to move, so your potential is 0. So that is the basic idea. So this condition, both conditions are important to find out the constant, and this is actually used for the boundary condition. Boundary condition means if you consider a particle which is quantum mechanical in nature, it will have a wave function associated with it, and that wave function is psi. Now if the particle does not exist in that particular point, it does not have any wave function associated with it, that means the psi will be 0. Okay, there is no particle, that means psi is 0 in simple words. So on the wall the particle does not exist, so on the wall psi is 0. So that means psi is equal to 0 at x is equal to a and x is equal to 0. X is equal to 0 may be exist nahi karta, psi is 0. At x is equal to a also it is 0, so that also it does not exist, particle does not exist. So this is actually called the boundary condition. Psi at x is equal to 0 is 0, and psi at x is equal to a is equal to 0. Now this is the entire problem that we have, and based on this we can find out its energy. That means what is the energy of that particle that is trapped inside the box. Interestingly, we are going to see that this energy is never going to be 0. Okay, that is something which quantum mechanics predicted. Even if something is in the ground state, it does not have 0 energy. That is one of the main conclusions of quantum mechanics. So let's say we are talking about a particle trapped inside a box of dimension 0 to a, and I am writing down the Schrodinger's time independent equation. This is the Schrodinger's time independent equation. Why? Because the potential is 0. Outside to bhul hi jao, wahan to hai nahi. Particle is only between 0 and a, So I am analyzing only in this position. So in this position, if I analyze, I know potential is 0. So if you look into this equation, here this is the potential, so this is 0. So that means the only two terms that exist is this and this. So that's why the equation is written as minus h cross square by 2m d square psi by dx square is equal to E into psi. Everything is a function of x here. Okay, we have written r before when we derived it, because r is 3-dimensional, ix plus j cap plus k z cap, k cap z and so on. Okay, this is 3-dimensional, but here we are talking only about a 1-dimensional potential. See, 1-dimensional potential. So that means the particle is moving only along x direction, although it is not real. Okay, in reality it will be 3-dimensional, but for beginners understanding quantum mechanics, we are just taking the 1-dimensional case. So this is our equation, or we can actually modify it further. We can take this 2m on this side and h cross square at the bottom, and take the minus sign also on this side, and I can write down this entire term 2me by h cross square as k square. So I have written k square as 2me by h cross square, and I have taken this, there was a minus sign, so I have taken it on this side. So I have got this equation, Now in maths we have studied about differential equation. This is that exact same thing. This is a second order differential equation, but this is periodic in nature. Since this is periodic in nature, the solution must have sine and cos involved, because if it is not periodic, it can be of different forms, but then this is periodic because we know it's a wave function. So I'm just taking the wave function as psi is equal to a sine kx plus b cos kx, periodic consequence, right? So this is my wave function. Now if I write down this as the wave function, that means this will be the solution for this. So what does it mean? It means that if I put psi is equal to this here and here, I should get 0. Okay, but for that I must know what is a and what is b. So the next challenge is to find out the value of a and b by using boundary condition. So what is our boundary condition? First boundary condition is at x is equal to 0, psi is 0. So we are putting psi is equal to 0 at x is equal to 0. X is equal to 0 means a sine x is 0, so a sine 0 plus b cos x is 0, so b 0. Cos 0 is 1, sine 0 is 0, this is 0, so b is equal to 0. So that means the first parameter is b is 0. So that means my solution is a sine kx now. So first condition I have used and I found out that the b is 0. So अभी मेरा solution और easy हो गया. This is sin kx. Now let's find out it at this position x is equal to a. At x is equal to a, that means psi of a is equal to a sin kx, x at jagah a, so I can write it out like this, is equal to 0, right? Now this will be only 0 if a is not equal to 0. This will be basically, if a is equal to 0, then only it is possible, or sin ka must be equal to 0, right? Because we know psi a is equal to 0, psi a is equal to 0. But a to 0 हो नहीं सकता. A 0 होगा तो पूरा का पूरा wave function vanish हो जाएगा. Like b is already 0. If a is also 0, then this wave function won't exist. But it exists. We know there is a particle. So that's why sin ka must be equal to 0. From the physics point of view, to understand that. So if sin k is equal to 0, that means what should be k? Sine of pi, 2 pi, 3 pi, 4 pi are zeros. So that means sine of n pi. So sine of k is equal to 0, and sine of n pi is also equal to 0. That means ka must be equal to n pi, where n is equal to 1, 2, 3 and so on. So if you look here, k, we can find out the answer is n pi by a. K is equal to n pi divided by a. So we've got one result here. Okay, but we need energy. But for energy, it is k square is 2me by h cross square. So in place of k, I can write down k square. So what will be k square? K square is equal to n square pi square by a square. N square pi square by a square. And what is k square before? 2me by h cross square. We have just written it here. 2me by h cross square. So that means k is equal to 2me by h cross square as well as n square pi square divided by a square. Now if you equate both of them, okay, you can equate both of them. I have written it in a different way, but you don't need to necessarily. You can simply write down that k square is equal to n square pi square by a square, but also k square is equal to 2me by h cross square. You equate both of them. You equate this, and when we equate this, you get the energy term as pi square n square h cross square by 2ma square, where this n value would be 1, 2, 3 and so on. So this is the energy eigenvalue. In simple word, it means that n is equal to 1 is closer to the nuclei, principal quantum number n is equal to 1. So this n is something which is representing the principal quantum number closer to the nuclear one. Next energy level is 2, next is 3, so that means you are talking about the principal quantum number 1, 2, 3 and so on. So please remember this n is the principal quantum number. So if someone asks you to find out the energy eigenvalue of a particle trapped inside a box, you have to do this much and find out this answer. En is equal to pi square n square h cross square divided by 2ma square. N is equal to 1, 2, 3 and so on. So what do we observe here? That n is not 0, n will always start from 1, talking about the first energy level, second energy level and so on. Ground state, n is equal to 1. Ground state, n is not equal to 0. Okay. So if n is equal to 1 is the ground state, that means n will become 1 here. But pi square we know, h is 6.36 into 10 to the power minus 34. M is mass of that neutron which is trapped inside the box. A is the width of that box. So if you see this, this is non-zero. So that means when n is equal to 1, that means the particle is at the ground state, there is still some value of the energy. So that means even at the ground state, the particle will have some energy. This is what is being concluded in quantum mechanics, which is very important. Now if you find out the next level of energy that that particular neutron or proton will be a multiple of the ground state energy. First it was 1, in the second it would be n square into E1, because this will remain as E1, this will always remain as E1, this is our E1, okay, because we take this. So ये E1 ले लेते हैं इसको, right? So this is E1. So if this is E1, next would be n is 2, so it will be 4 into E1, next would be 9 into E1 and so on. So that means the energy gap will keep on changing. Okay, here it will be E1, then it will be 4 times E1, 9 times E1. So the difference in gap will keep on increasing for that particular quantum mechanical particle which is trapped. Please remember, this is only valid for atomic particle. We are not talking about real life macroscopic objects here. So it is a multiple of these energies. Okay, it will be a square of that number. So that means these energies are fixed, and that is why it is called quantized. So the energy is quantized. This is the basic idea. So we have found out the energy, but please remember, we have not yet found out what is the wave function. Wave function we have just seen that psi x is equal to a sin kx. So b का तो हमने 0 निकाल दिया था, but psi x is equal to a sin kx. But a तो हमने निकाला ही नहीं अब तक. We have to still find out a. Okay. Now comes a very important point, that this psi that we are actually talking about is representing the wave function, but it does not have any physical significance. In simple word, it means that it might have an imaginary term, and an imaginary term is not something which is having any physical significance. But if you take the square of this will give you the probability of finding that particle. Mane, if you have a neutron and if it is trapped inside the nucleus, what is the probability of existence of that neutron inside the nucleus? 1. Okay, because it will be inside the nucleus, it cannot be outside. Outside it's 0, so it is always equal to 1. So that means if I take psi square, this is going to be equal to 1. That means that the particle will exist there. So if I take a psi square for this, okay, and I take this psi square for the entire region, what is the region? 0 to a. So the normalization condition says that if I take the wave function square over the entire region is 0 to a. Mine is not minus infinity to plus infinity. I know it exists within the nucleus. It cannot exist outside anywhere. Okay, not even on the wall. So that's why I just take it from 0 to a. Psi n square dx. So this will be the total probability, and this has to be equal to 1 because this is the total probability. So if we integrate this, okay, this psi n was nothing but a n sine square n pi x by a, because if you recall this is sine kx, and what was my k? K is equal to n pi divided by a. So আমরা কি করব, k এর জায়গায় বসাবো n pi by a, x থাকবে এখানে. So a n square বাইরে আসলো, 0 to a sine square n pi x divided by a into dx. So this is equal to a n square into, now if you integrate this sine square theta, you have to recall again basic trigonometry. We know that sine square theta is equal to 1 minus 2 cos 1 minus cos 2 theta divided by 2. Okay, so you can use that relation, and then you can find it out, and then you can replace the limits and put it, and you are going to get this as a by 2. Please remember this. Okay, this is becoming too hazy, so let me just rub this off. Yeah. So this actually becomes a by 2. if you integrate this is a very simple integration, don't worry, you can do it. Modulus of a square into a by 2, this must be equal to 1 obviously, because this is the entire probability, this must be equal to 1. So what will be an would be, you take 2 here, a will come here, root 2 by a, and an square ka root le lenge, so an would be root over of 2 by a. So this is my an value. So what was our wave function? Our wave function was psi x is equal to a sin kx. So we can write down as psi x is equal to a ki jagah root 2 by a, sine of k ki jagah n pi by a into x. Now if you look into this wave function, you will see that all the parameters are known to me. Let's look into the parameter. Psi x is the wave function associated with that wave, that means with that particle, that means it may be a neutron or a proton trapped inside the nucleus, can be a good example. 2 by a. A is the width. So if it is inside the nucleus, a value would be 10 to the power minus 15 meter into sine n. N means which energy level we are talking about. Are we talking about the wave function in the first energy level? Then n value would be 2. If it is in the ground state, n would be 1. Okay, please remember this. Ground state, n ka value 1. First excited state, n ka value 2. It's not 0 in the ground state. Next, pi we know. X is that particular position at which I want to find out whether the particle exists or not. So that is x, divided by a is again the width of that. So this is exactly the solution, and based on this we can interpret different kinds of things. For example, this I have already told you, that quantization of energy, it will be always a multiple of E1, 4 into E1, 9 into E1 and so on. So that means the ground state will never have zero energy and it will always be quantized. So upper energy level will be fixed, above that also it will be fixed and so on. Next, ground state and 0 point energy. So as I said, the 0 point energy means n ki value 1 hai, and then you can find out what is the value of n for this. Okay, you can calculate it, depends on what particle you are considering. Okay, it may be a proton, then mass would be something above for proton. If it's a neutron, it will be for neutron, or any other subatomic particle. You should know what is the dimension in which it is trapped. So a is the dimension. If it is inside the nucleus, a value is 10 to the power minus 15 meter and so on. And this is definitely non-zero. So the particle cannot be completely at rest, okay, even if you are confining it in a very small space. So imagine something which is getting confined within 10 to the power minus 10 or minus 15 meter. It is always going to be it's always going to be having some energy, and as you keep on reducing the space, that means if you keep on reducing a, you will see that the energy will keep on increasing because a is at the denominator. Reduce karoge to energy badhega because it's a denominator, so that means energy will keep on increasing. So you take a particle, you trap it in a very small space, the energy will more or less keep on increasing. So this is the idea. Nodes and probability distribution, let me tell you, probability means that the existence of particle, so it is always the wave function square. So if you want to find out the total probabilities, it is 1, but at a particular point you have to just take the square of this, so you'll know what is the probability of particle existing at that particular point, because it always is between 0 and 1. Nodes, I'll just tell you now, I should draw the diagram and tell you. Node degeneracy, so if we are talking about a particular energy level, it has got just one energy eigen function, okay, that is the basic idea. So this is exactly what happens, okay. So these things are basic idea. Most important are the initial points that I'm talking about, okay. So you have to remember this is the wave function that we have, that we should derive for a particle trapped inside a box. Very important question, and we derive it from Schrodinger's time independent equation. Just remember that V0 हो जाती है particle box के अंदर है, तो P को हटा दो, just solve it, you're going to get this answer. And next is the energy eigenvalue. So this is my energy eigenvalue. Now if I want to plot a graph, for n is equal to 1, let's say, if I want to plot a graph for this wave function, so if I put n is equal to 1, I've got this expression, okay, this expression. Now at a is equal to 0, that means on this end, if a is equal to 0, okay, sorry, at n is equal to 1, yeah, of course, this is a is equal to 0, and this side you know, a is equal to L, or a is equal to a, we can say, right? So if you put that result, if this is 0, so this will become, entire thing will become 0, okay, and this side also 0, and in between you will be having the maxima, okay. Maxima means think about this expression here, okay. If you think about this expression for maxima, sorry, at x is equal, not a, sorry, x, right? A is fixed, a is the width of that well, okay, I'm not saying a, it's x, right? So we talk about from here to here, here it is 0, here it is a, in between somewhere it will be x, At this particular point, x and a are equal. Okay, so if I take at x is equal to 0, this is sine 0, and sine 0 is 0, that's why it is 0. At the other extreme point, at x is equal to a, I can write down a here. A get cancelled, sine of n pi, again it becomes 0, so again it is 0. If you look into the maxima, that means it will be a by 2. So that means let's take x is equal to a by 2. So this a gets cancelled, it will be n pi by 2. So n is equal to 1. If you talk about ground state, it will be pi by 2. And sin pi by 2 is maximum. Sin pi by 2 is 1. Okay, so you get the maximum value. Okay, so I hope it is not very complicated. You take at x is equal to 0. Okay, if you take x is equal to 0, psi is equal to 0. You can put it here. You can see it's 0. If you take x is equal to a, psi is equal to again 0. Why? Because if you take x is equal to a, this will become a, and then this a and this a will get cancelled, sin n pi, it will become 0. But if you take in between, x is equal to a by 2, then psi would be, okay, psi would be maximum, max. How? Because if I take it as a by 2, this a gets cancelled, it is n pi by 2, n was 1 ground state, so it is pi by 2, sin pi by 2. So sin pi by 2 is 1, so I will be getting the answer as root over of 2 by a. So at this particular point, okay, this is root over 2 by a. So that's easy. Okay, so that means at n is equal to 1, how many nodes we are getting? Okay, we are getting only 1, right? So that's n minus 1. So it's always 1 less. Okay, it is always 1 less. So that's important. So let's take n is equal to 2. N is equal to 2 also you can do. You can see that at 0 and a both are becoming 0, so it is having 0 0 here. But if you take it as pi by 2, at pi by 2 in between, a by 2, sorry, if I take a by 2, here it will be a get cancelled, it will be n pi by 2, but n is 2 because we are going into the second energy level. So that 2 will also get cancelled, and I'll have just sin pi, and sin pi is 0, so that means again I'll have a 0 here. So this will form one complete wave. So this is how you draw the energy wave function diagram. But remember, this is for psi nx. But if you want to draw it for modulus, that means the probability of finding the particle, then it will be very simple. It is just positive. Everything would become positive here. Okay. So if I talk about this, let me write it down in short. In the ground state, it will be the same. It will be the same. In the first excited state, since it is square, okay, this is first, so this is one, this one. But this one won't be down, it will be on top as well. It will be like this. You can do the maths and check. How? Because this is square, na? So you are not going to have any negative values. It's square, so you are always going to have the positive value. So this is this one. Okay. So this would be n is equal to 1. This is n is equal to 2. For what? This is for psi square, not psi. Psi square. ये वाला psi के लिए है सारा. This is psi. So if you go for n is equal to 3, it will be 1, 2, and 3. This is n is equal to 3. So that's how it works. Okay, and these things are repeated, so don't want to repeat this. This is clear. Okay. So this is an important conclusion. It is always multiplied with n square. So these are not equally spaced. If it was multiplied with n, then it was equally spaced, right? But it is not. It's n square, so it's not equally spaced. 1, 4, 9, 16, and so on. It will keep on moving. Okay. So physical significance, I'll share this with you. This one I've already discussed. If I talk about the square, then only it has got a physical meaning. That means it will be there. The particle will exist. Okay. This is an important conclusion. Single valuedness. That means this wave function at a particular point will have a unique value, one single value. That's very important. This is having continuity everywhere. That means if it is within the box, you consider any point, the next point won't be an infinite point. Okay, it will be having some value. So it is more or less continuous everywhere. Normalizability, because the particle will exist somewhere in space, so it has to be equal to 1. So this is the normalization condition, minus infinity to plus infinity. हमारे केस में तो from 0 to a, I can take it from minus infinity to plus infinity, but then on other points it does not exist, it is trapped, so that means it has to be between 0 and a. So this is normalizability of condition. Continuity of derivative, okay, that means if I derive one parameter with respect to another, okay, do the derivative of that, it will be having some value and it will be continuous, okay, that is also there. So this is what are these things, okay, these are just additional points that you can go through, but then these are the most important parts here. Okay, so that's all about Schrodinger's time independent and dependent